Dear learners, hope all of you are fine. I am also fine. Today I am going to discuss about the creative question based on pH calculation and buffer solution. Look at the whiteboard. There is a creative question in the whiteboard. The first one is calculate the pH value of container A. Container A contains 0.01 mole ethanoic acid 20 ml. So, dear students, now I would like to show you the solution of question number 1. We know that concentration S is equal to W into 1000 divided by M into V. You know that my dear students, you know that weight divided by molecular mass of compound is known as mole number. So I can write here 1000 divided by V into N. Here N is equal to mole number, as N is equal to weight divided by molecular mass, and it is given volume V is equal to 20 ml, mole number N is equal to 0.01 mole, and concentration S is equal to what? This is for container A. For container A. Now I am going to put the values from the given data. 20 into 0.01, so S is equal to 0.5 molar. As this is a weak acid, all of you know that weak acid ionizes partially. So ethanoic acid ionizes partially to produce ethanoate ion and H plus ion. Dear students, all of you know that in case of weak acid, Ostwald's dilution law is applicable during the calculation of pH value. That's why I have to use here Ostwald's dilution law for getting the molar concentration of this H plus ion. So from the Ostwald's dilution law, we know that alpha is equal to root over Ka by C. Here Ka dissociation constant is 1.8 into 10 to the power minus 5, and concentration C is equal to 0.5 molar. Dear students, it is stated that S is for strength. Strength means concentration. And concentration is also denoted by C. That's why I have written the value of C is 0.5 molar, which is calculated at the first part of the solution. So alpha is equal to root over 1.8 into 10 to the power minus 5 divided by 0.5. So alpha is equal to 6 into 10 to the power minus 3. H plus, so molar concentration of H plus is equal to alpha C is equal to, the value of alpha is 6 into 10 to the power minus 3, and the value of C is calculated here, it is 0.5. So it will be 3 into 10 to the power minus 3 molar. And we know that pH is equal to minus log H plus is equal to minus log 3 into 10 to the power minus 3. So pH is equal to 2.523. This is the answer. Now question number 2. Calculate the pH value of container B. Container B, you are seeing that 0.8% sodium hydroxide 30 ml. 0.8% sodium hydroxide, 8% sodium hydroxide means 0.8 gram sodium hydroxide is dissolved in 100 ml solution. Dissolved in 100 ml solution. Dear students, again we are going to use the same formula. S is equal to W into 1000 divided by M into V. Here W equals to 8 gram, 0.8 gram, it is given in the question, and molecular mass M is equal to 40. Dear students, all of you know that molecular mass of sodium hydroxide is 23 plus 16 plus 1 is equal to 40, and V is equal, V means 100 ml, as it is percentage, that's why the volume you have to count 100 ml. So the result is 0.2 molar. My question is calculate the pH value sodium hydroxide. All of you know that sodium hydroxide is a strong acid, that's why sodium hydroxide ionizes in the aqueous solution completely to produce sodium ion and hydroxide ion. So in this case I can write directly POH is equal to minus log molar concentration of hydroxide ion is equal to minus log. Already I have calculated the concentration, molar concentration of hydroxide ion. My dear students, you may have doubt at this point because at the first part of this solution I have calculated the molar concentration of sodium hydroxide, but here I am putting the value of 0.2 in the place of hydroxide ion. Main point, actually sodium hydroxide is a strong acid there and it ionizes to produce, completely ionizes to produce sodium ion and hydroxide ion. That's why the molar concentration of sodium hydroxide is equal to the molar concentration of hydroxide ion. That's why I can write here 0.2. So POH is equal to 0.690. We know that pH plus POH is equal to 14. So pH is equal to 14 minus POH is equal to 14 minus 0.690. So pH is equal to 13.31. This is the answer of question number 2. Now my dear students, look at the question number 3. Calculate the pH value of the mixture of container C, and it is given that both of the container A and B are mixed here. First you have to prove that which type of mixture will be get in the container C. That's why I have to show some calculation. Look at the container A, dear students. First I have to confirm you, I have to remind you that I have calculated in the question number A the concentration of container A is 0.5 molar. I have calculated in the first question, and in the second question also I have calculated the concentration of sodium hydroxide is 0.2 molar, and those data will need for doing the answer of the question number 3. So my dear students, I can write here 20 ml 0.5 molar ethanoic acid, 20 ml 0.5 molar ethanoic acid is equivalent to 20 into 0.5 ml 1 molar ethanoic acid. My dear learners, you know that there is a formula for the conversion of the molar concentration in 1 molar, and I would like to just remind that formula: X ml Y molar solution is equivalent to X into Y ml, Y divided by Y molar solution. Then it will be X Y ml 1 molar solution. This is the actually equation. However, my dear students, I have applied this formula here, 0.5 divided by 0.5, that's why I have written here 1 molar. Now you may ask me, sir, why did you convert the concentration of ethanoic acid 0.5 molar into 1 molar? Why did you convert it? Because I will compare the volume of ethanoic acid and sodium hydroxide. In that case, the concentration of ethanoic acid and sodium hydroxide are different to each other. That's why I have to convert both of the concentrations in in 1 molar. That's why I have applied this formula. However, this is from actually container C for vessel A and for vessel or container, no problem, container B, vessel B, this is 30 ml volume is given here, and the concentration was calculated. The question number 2, 0.2 molar sodium hydroxide is equivalent to 30 into 0.2 ml 1 molar sodium hydroxide. Then it will be 6 ml 1 molar sodium hydroxide. When we will mix the solution of container A with the solution of container B, that time the following reaction will take part, and that reaction is ethanoic acid plus sodium hydroxide is equal to sodium ethanoate. You know that sodium ethanoate is a salt plus water. Dear students, the volume of sodium hydroxide, the converted volume of sodium hydroxide is 6 ml. That's why I have to write here 6 ml. Mind it, the volume of ethanoic acid here 10 ml 1 molar ethanoic acid. Dear students, mind it, 6 ml 1 molar sodium hydroxide reacts with 6 ml 1 molar ethanoic acid to produce 6 ml 1 molar sodium ethanoate salt. It is noted that you have to consider the lower volume in between ethanoic acid and sodium hydroxide. The produced salt, the volume of the produced salt will be equal to the lower volume of acid or base. Here the lower volume is actually 6 ml of sodium hydroxide. Then I can write here after reaction the remaining the remaining ethanoic acid is equal to the volume of ethanoic acid is 10 ml. So, and here 6 ml takes part in the chemical reaction. So, the remaining 10 minus 6 ml, and in all cases the concentration is 1 molar. That is why you need not bother about any concentration. Is equal to 4 ml 1 molar ethanoic acid. So, I can say here the produced or the obtained mixture is actually acidic buffer solution, because here the remaining solution is ethanoic acid and the produced salt is sodium ethanoate. Ethanoic acid is mixed with sodium ethanoate to produce a acidic buffer solution. And in case of acidic buffer solution, we have to use the Henderson-Hasselbalch equation for the calculation of pH value, because in the question number 3 it is asked for the calculation of pH value. That's why first I have to prove that the mixture of C container is actually acidic buffer solution. Then I can use the Henderson-Hasselbalch equation for the calculation of pH value. It is noted that Henderson-Hasselbalch equation is only applicable for acidic buffer solution. So, let's write the Henderson-Hasselbalch equation. This is pH. pH is equal to power Ka plus log salt, molar concentration of salt, divided by molar concentration of acid. And we know that power Ka is equal to minus log Ka plus log salt, molar concentration of salt divided by molar concentration of acid. And the dissociation constant of ethanoic acid, Ka, it is given in this term. That's why I can write here 1.8 into 10 to the power minus 5 plus log the molar concentration of salt is 6 and acid is 4. Dear students, you may have doubt at this point, because here I have written the molar concentration of salt, but I am putting here the volume of salt. Now you may ask me, sir, why did you do it? Because in both cases, the concentration of salt is 1 molar and the concentration of acid, remaining acid, is also 1 molar. When the concentrations of both salt and acid are equal, in that case you can write the volume as molar concentration. That's why I have written here 6 and the remaining volume is 4. I think you got your point. Now again, my suggestion to all of you to calculate the whole equation by one step through the calculator. Here the pH value is 4.92. This is the answer. Now dear students, look at the question number 4. If a small amount of hydrochloric acid or sodium hydroxide is added in the container C, then will the pH value be changed? Analyze it. Dear students, already I have taught you about the buffer solution. Though I have taught you, but I would like to again repeat just a little bit. The solution whose pH value remain unchanged after addition a small amount of acid or base is called buffer solution. There are two types of buffer solution. One is acidic buffer solution and another is basic buffer solution. However, dear students, if I consider the container, if a small amount of hydrochloric acid is added in the container C, if I consider container C, already I have proved that container C is actually acidic buffer solution. I have proved it in the question number 3. And there in the container C, the remaining ethanoic acid, you know that ethanoic acid is a weak acid. The remaining ethanoic acid is mixed with the produced sodium ethanoate to produce the acidic buffer solution, to produce the acidic buffer solution. So I can write here, this is acidic buffer solution. Acidic buffer solution. As ethanoic acid is a weak acid, ethanoic acid ionizes partially in the aqueous solution to produce ethanoate ion and H plus ion. And again, sodium ethanoate, it is a strong electrolytic substance. I mean, sodium ethanoate ionizes in the aqueous solution completely. That's why I am giving here one-way direction reaction, one-way direction sign to produce ethanoate ion and sodium ion. If I add a small amount of acid, I mean hydrochloric acid, small amount of acid, then H plus ion of acid, H plus ion of acid combines with the ethanoate ion of acidic buffer solution to produce ethanoic acid. The produced ethanoic acid is a weak acid, that's why it remains as unionized in the solution. Unionized in the solution. So after addition a small amount of H plus ion, I mean hydrochloric acid, in the acidic buffer solution, the concentration of H plus ion remain unchanged. That means the pH will remain unchanged. Again, if I add a small amount of sodium hydroxide with the acidic buffer solution, that time hydroxide ion of sodium hydroxide combines with H plus ion of acidic buffer solution to produce water. And the unionized ethanoic acid exists at the equilibrium state, again ionized to reproduce the same amount of H plus ion, which is neutralized by hydroxide ion, external hydroxide ion. As a result, the concentration of H plus ion of acidic buffer solution remain unchanged, and the pH value will also be unchanged. And so finally I can say, if a small amount of hydrochloric acid or sodium hydroxide is added in the container C, then the pH value will not be changed. That's all about the today's lecture, my dear students. No more today, and goodbye.